Hello guys, welcome back to my channel. So today we are going to discuss regarding the SPM Additional Mathematics 2021. So as you can see, this is my suggested answer. So I have answered all of the questions for this paper 1. So the time allocated is 2 hours. And for your information, basically for Additional Mathematics 2021, so they are implementing the new syllabus which is under KSSM. Alright, so without further ado, let's just discuss, because I've answered all of them. So we'll just talk a little bit about my answer over here. So for your information, this is my suggested answer. So it might be at some circumstance could be wrong, could be any mistake. So I hope you could do double check for my answer. Okay, so for question 1 is asking for the area. Okay, so area of what? Of the major sector. Alright, so which means that you are focusing on this. So if you still remember, the area for the sector is half r squared theta in radian. Okay, so theta, you need to find the angle of this. Okay, angle of the major sector, OAB, which is, in this case, is 2 pi minus pi over 3. Okay, which is 5 over 3 pi. And then just subs in, you'll get the correct answer. Alright. Okay, so for question 2 is linear law. So you need to remember that the formula for the linear law is basically y equals to mx plus c. So y here is the y-axis, x here is the x-axis. So in this case, our x-axis is ln x and y-axis is ln y. So just subs in y-axis and x-axis. In this case is ln y equivalent to m ln x plus c. So you want to find the gradient. So the gradient in this case is based on the ln y and ln x axis. Okay, so you cannot like, so you know that the equation is ln y mx. So the gradient is from this graph lah, and ln x, right? Ln x. Let's see. So you cannot use, for example, you take coordinate to 1 and you subs x equals to 2 like this. So y equals to 1 and m ln 2. Let's see. So this is actually wrong. Why? Because the coordinate here is not actually xy for xy coordinate. We already changed the coordinate into ln y against ln x. So you need to remember that. So this is correspond to ln x and this is ln y, which means you need to substitute the ln x is 2 and ln y is 1, like that. Okay, so that's a little bit. Okay, so for question 3, it's not a big deal actually. So it is a geometric progression. First term is 217 and common ratio is 2 over 3. So I have listed over here. Okay, probably you can see. And then just apply the formula of sum of the geometric progression, which is this. Because the question A wants what? It wants a sum of the first n terms of the progression less than 650. So I set the Sn to be less than 650. At the end, I just solve the equation, the inequality. I get this n less than 15.98, which means that the maximum value should be in the whole number, which is 15, the maximum. Okay. So for question B, so it is just the difference between the fifth term and then sum of the all terms. So sum of all terms here means that S infinity, right? So S infinity for geometric progression is this. Okay, so this is infinite series, infinite sum. So Tn is this formula. So just apply, substitute T5 because the question want difference between T5 and S infinity, and then just evaluate the value. You get this as the final answer. Alright. Okay. Question 4. Okay, so question 4 it is given that the equation of curve is this, and you want to find the gradient function. So the gradient function is basically the gradient, which is the dy dx. Okay, so that's the definition for the gradient. So just find the derivative. So B. Okay, because the line touches at point P, okay, and the straight line is perpendicular to the straight line, the straight line of the pink one over I already drawn for you. The pink is perpendicular to this, the purple one, which means that we can use the m1 m2 equals to -1 for the perpendicular, the mutually orthogonal or perpendicular line. Okay, so we know that one of the gradient is -2, the purple is -2, so we know that the pink one should be 1/2. Okay, 1/2. So we know that the gradient of the pink is 1/2. So what we did, we just substitute into the gradient function, is it? So because we know that the gradient function is this, so we just equate to be 1/2 because the gradient of the pink is 1/2. Then just solve for x, you get x equals to 2, and we need to get the y coordinate point. Just substitute into the original one, right? So you do not substitute into the gradient function. We need to substitute into the original function. So you get this 2.5. Okay, so P is 2, 2.5. Alright. Okay, so for question 5 is not so hard, I guess. So for question 5, you need to find the range of value of x such that fx is greater than 0. So always remember that from this origin to the top is fx greater than 0, and below that, bounded by this curve and also the y-axis, y-axis from here to here, bounded between the curve and the y-axis is this. So this is actually fx less than 0. Okay, so you need to remember this. But in our case is bounded between the curve and also the y-axis, the x-axis is between this part and also this part. So you cannot include the inside one lah, this one. So you don't have to include that. So only the bounded by the curve. Okay, bounded by the curve and also the x-axis. Okay, so we just apply the like this. So this is our equation, our function, and then just apply the inequality because fx is greater than 0, which means this function should be greater than 0 too. So this is actually quadratic. Just factorize like usual, and you get two possibility. So you get two roots, so -4 and 1. So -4, the inequality is satisfied. That is when the x value is less than -4, which is to the left, and also when x value is greater than 1, to the right. Okay, for question B, you need to remember what? B1. Okay, px plus q minus fx equals to 0. So I make the equation like this, okay, in standard form. And you need to remember that sum of root SOR is minus what? Minus b over a. Product of root is c over a. You need to remember that. and then you get SOR and POR, then you are in the safe zone lah. B2, this is easy actually. So same logic, SOR is just plus the roots, because the roots given 2 divided by alpha and 2 divided by beta. So 2 alpha plus 2 beta is minus R, because this is the B over A. So A is 1. So minus R lah. Okay. And then the POR is this. You just multiply 2 divided 2 over alpha times 2 over beta. So you get 4 over alpha beta. And POR is C over A. So C here is this. So this is C. This is B. This is A. So A is the coefficient 1. Okay. So you got R minus 10. R minus 10. So you get first equation. Okay, and then the second equation lah. This one. So what I do, I just substitute lah, because the question wants what? Express P in terms of Q. So you still see R. So I make R as the subject for the first equation over here. So I make R as the subject, so I get this lah. So R equals to this term, this fraction, then I just substitute into P. So this is still got R, right? So I just I just replace R. So this is R, so I just replace into here. Then I will get anything, the term to be everything in Q. Okay, so we already replace the R lah. Okay, for question 6. So this is quite tricky actually. Okay. So you just read the question carefully. So sector ABHG. So ABHG. So this part ABHG. So it's a quadrant. So it's a quarter circle. Center A. So this is the center. And HD is a sector. Arc of the circle. So A from here to here. The center is B. Okay, so you need to remember that. So I already drawn question A. Find the angle. So angle is easy because you know BC is 8. Okay. How do I know 8? Because the question gives BC is 8. BC is CE. BC equals to CE equals to 8. Okay. And CD equals to 3DE, which means that you need 3 units of this to achieve this length. So you can calculate that this part is actually 2 units lah, or 2 cm, and this is 6 cm. So total is 8 lah. Alright, so we need to find the perimeter. So perimeter, we need to find the arc length of this S1. Okay, how I find S1? S1 is R1 theta. So that's the formula. So I hope you still remember S equals to R theta. So R here is 10. How do I know 10? Okay, because from the term, first of all, let's have a look on this from B to here. So this is actually the radius of the circle A. Of the sector AHD. So this one. So the radius is this. So how to find the radius is to use theorem Pythagoras, because we know this side is 8, this side is 6. So we know that the radius should be 10 lah. So the radius by definition is from the center point to the circumference. So this is from the center to the circumference. So we know that the radius is 10. And we use the same logic. Okay. We can prove that the radius of a quarter circle is actually 10 also. Okay, it's actually 10. Why? Because this is actually the common radius for the both quarter circle and also the sector, the big sector. This is actually the radius of the big sector, AHD, 10. And also, if you see that this is actually the radius of the quarter circle too, because the quarter circle is from here, from G, B, A. So this A is the center, and this is the circumference. So this is 10 as we noted just now. So they have the same radius, common radius, 10. So we just apply the S equals R theta. So both circle has the same radius, 10. And for S1, the theta is 30. So you can prove that from here, simple relationship. So 30 just change in radian because the formula is for in radian. And the S2, you need to find the circumference. I mean the arc length, well, not the circumference, arc length. For that, because we know that this is 10, because 10, 10, 10. Why? Because by definition, it is the radius for the circle. Same length, so this is actually equilateral triangle. Okay, so we know that this interior angle is 60. Theta, we already find the theta, and then we want to find this angle. That angle is just 180 minus 60 minus the theta just now. But you need to change everything in radian. So that one is this lah, I already write for you. And the hardest part for this question is actually to find the length of FE. How? So, because we know that, let me erase this everything first. Okay. Because you know that this is 8. So this is from here to here is 10 lah by definition. Okay, we already discussed about that. Because that's the radius of the circle. I mean the quarter circle. So we know that this part only is 2 lah. Okay. So this part is 10 plus 8, 18. And we want to use theorem Pythagoras, so we just add, because we know from F to G is 10, from G to this is 2, so this is actually 12. All together is 12. So all together is 12 from here to here, 12. So apply the theorem Pythagoras, you will get this 21.6333. And then the last length you need to add is this lah, 10, the last one. Okay, because it includes that too. So it just adds up everything, you get this answer. Okay, nice. Question 7. So you can read first. So it is a parallelogram. Okay, A, state the value of ED, vector ED. So vector ED, okay, vector plus vector DB, plus BE. So this is because you initially runs from your place and then you get back to the original place. So by definition, because this is vector, so we are talking about displacement. Okay, so the displacement is 0 lah, because it doesn't because the initial and the final position is the same, 0. B, a path from station E to station D is parallel to x-axis and displacement is 11 meter. Using vector triangle law, find the resultant force resultant vector from station E to C. So from here to there, right? So by definition, you can use the additional of vector. So ED plus DC. Okay, because you know ED is actually, you just minus the position vector, 12 minus 1, 11, Okay, so and 1 minus 1 for the y coordinate, so you get 11 0 like that. You need to plus with the DC. Okay? So DC is from this point to this point. Okay, it is actually similar to the length of this lah, from this E to B. So it is similar. So you can find from here, or you can just first you find C first, then you minus from the position vector of D. But I just use this 5 minus 1 is 4, 11 minus 1 is 10. So 4, 10 lah. Just add the vector and then you get 15, 10. Okay, in the component form. Okay, question C. A boy runs from station E to a cone at K 5, P with a constant velocity. Okay, he takes t seconds to reach the cone. Based on the information given, write a vector equation. So this is actually we are given the velocity. So because we are given velocity, we can find displacement. So displacement is s lah. So this is actually in vector, ds dt. We just integrate both sides. So from s equals to 0 to s naught, and then t from 0 to t. Okay, we get this equation. Okay, vector equation. Okay, so this is st is actually e vector ek. Okay, vector ek. This vector, because the position, the displacement vector we solve is actually the ek lah itself. Okay. And s naught, what is s naught? So s naught is basically the position vector of E, because we start from E. Okay, because the limit I put over here, s equals to 0 to s naught, is basically sorry, this is actually a mistake. Actually, it's supposed to be s naught until s, like that. Okay, s naught until s. So we start from s naught. So s naught is E to s itself. All right, so we get s naught is actually 1 1 lah, because we start from here 1 1, E from position vector E 1 1. st is the final position. Our final position is where? Dekat K lah, 5p. Okay, and then this is actually the displacement lah. Okay, the displacement vector, which we differentiate just now. Okay, sorry, we integrate just now. Okay, so this is the result basically for the vector ek. So this is actually vector ek lah ni. Okay, so this is wrong. Right, so we want to find value of t, so we just compare the components. So 5 minus 1, what is 5 minus 1? 4. So 4 equals to 3t. So just compare this and then compare this bottom. You will get the answer. Okay, so for question 8, so this is geometry question, right? Okay, coordinate geometry. So we need to derive the line segment formula. So this is actually the longer step I did. I mean the most the mark given is only 2 marks, and I solve it using this is not the hardest way, but it is quite lengthy, but it's okay. How I did it, so it's basically simple. So first I consider EB. So this is EB, the horizontal distance. EB over FC. So this. So I just compare the ratio, because I know the ratio from A to B, M, and B to C is N. So it must also satisfy the ratio of E is B is also M, and also FC is N, like that. So that's why I wrote like this. And then that's for the horizontal distance or length. For the vertical, we have AE, the ratio is M, and also BF, the ratio is N, like this. So I just solve the both equation and I get X and Y coordinate, which is the coordinate of B, which give rise to the formula of the line segment, like that. For question B, given that A is 3, 2 and B is 6, 0, we need to find the range of value of R and S. So this is actually you just use the formula from the previous question. So we know X, I just compare this with this, and this with this. Okay, so it's the same logic. This with this with this. Okay, the difficult part is to determine the inequality in this part, because you need to keep in mind that M and N is always greater than 0, which is always positive. So if M equals to N, because the condition given in the question is M less than N. Okay, so if M equals to M first, we get N equals to M, which is 1. N divided by M is 1. So 6 plus 3 is 9 lah. But if M equals to if M less than N, okay, just imagine you have for example, I put some value 9, maybe I can use 2 is less than 9, right? So you just put M equals to 2, N equals to, maybe I should use the whole number 3, like that. Okay, so M is 3, N is 9, so 6 plus 3, so N is 9. This is example. So you get 6 plus 9 over 3, which is 3, times 3 is 9. So this is 15. Which means that this should be greater than 9. Okay, always greater than 9. Because when you have denominator less than the numerator, then you will have improper fraction, which give you a whole number. So a whole number times with a 3, you will give rise to the whole number, which is greater than 3 should be. So 6 plus something greater than 3, you will get something greater than 9. So that's why my conclusion is R is greater than 9, greater or equal to, because we need to consider the both condition. Okay, equals to M equals to N, and M less than N. So you just apply the same logic. You need to keep in mind that M is greater than 0. You will end up with S less or equals to minus 2. Okay, you just use the same logic like this. Okay, question B2. Find the value of P, the straight line x over 6 plus y over P is 1. So this is in intercept form, I guess. So in intercept form, we know that x and y intercept is the denominator, but you need to remember that the plus sign between. Alright, and the formula for this is M equals to y intercept divided by x intercept. Don't forget the minus sign. Okay, so this is only for this formula of the straight line. So you find the gradient for MAB, which is minus P over 6. You just equate with the MAB, gradient of AB is minus 2 over 3, sorry. Okay, minus 2 over 3. And then you find the gradient from this intercept form equation, which is minus P over 6. Then you just equate lah. You just equate. You get equals to 4. Alright, it's very easy. Okay, question 9. We need to find the equation gx given that y equals to gx is this, and also the equation of y is this. Okay, all right. So it is given that the area under the curve y equals to gx is represented by this. So the question already helped you to integrate, okay, and then you need to get the equation of gx. So you just what you need to do is just differentiate it back lah. Okay, so differentiate it back, you get this. Okay, question B, the area of the shaded region. So the area of the shaded region is the area of under the curve of this equation, or I mean of this curve. So you find that area first, the whole area, and then you minus with the what? You minus with the area under curve of this, the blue one, which is the gx. Okay, area under curve of gx between 1 and 2. So I find the area under the curve of the gx from 1 to 2 is 1, and the area of the the red one is, you just integrate this curve from 1 to 2. So I get 1.75. You need to minus with the blue curve, blue area, blue region, which is 1. So you left with 0.75 unit. So this should be unit square, because it is area. Okay. Alright, so for question 10, I will explain because this is actually a bit complicated, not so hard but complicated. Okay, the aluminum rod has a length of 55,440 millimeter and can be cut exactly into 72 sections. The length of the first sheet is x millimeter, and the length of the subsequent sheet is increased by 20 millimeter. Athan is assigned to cut the aluminum rod. So this is actually arithmetic progression. So A, just state the length in millimeter of the first 3 aluminum sheets in terms of x. So because the first term is x and it is incremented by 20, so the common difference is 20 millimeter. So first term is x plus 20, then plus 20. So that's the second and third term. Okay. Alright, so because for question B, so Atan has completed 2 over 3 of his tasks. So by determining the value of x, calculate the total length in millimeter of the last 18 sheets that have been cut. So 2 over 3 of the tasks, which means that, okay, because the aluminum can be divided into 72 sections, so we have T1, T2, T3 until T72, because we have 72 sections. He only able to do 2 over 3, 2/3, which is 48 section. So our mission is to find the 18th last aluminum sheets that have been cut, which means that we need to find the sum of the term from T31 to T48. We need to add from T31 until T48. So this, by the mean of, you find the sum of all 48 terms, and then you minus with the sum of the first the t term. So we'll get the left behind is the last 18 section or last 18 sheets of the aluminum, like that. Okay, do you understand? So it's like, so for example, this is 1 2 3 4 5 6. So I just want to find the last, so this is actually an example. I want to find the last 3 of this. So how I can do that? So first I can find the whole sum. Okay, and then the whole sum is 1 2 3 4 5 6. So S6 minus with the S3 lah. Minus with this S3. So I left with the S4 until 6. So that's how the simplest, the simplest case lah, because it is impossible for me to show until 48 section and then I show you like this. So I just make it for example only 6 section, and you want to find S4 until S6, you can do, you find the whole sum until S6, and then you minus with the sum behind S3. You will get the sum of this plus this only. Okay, but before that we need to find the value of x. So because we know that the whole term is until 72 terms or 72 sections of aluminum, and the whole aluminum has length of 55,440 millimeter. Sorry, 55,440 millimeter. So we just subs S70 is using the formula equals to this. You get x equals to 60. After you get the value of x, then you can proceed for proceed for what? For this. That's why this is actually the continuation. Then you get the answer of 14,940 millimeter. Okay, for question C. So actually Atan want to form an open cylinder at both ends in 2 different ways. So when Atan completed his task, so which means 72 until 72 section, his brother has chosen the last sheet, which is the 72 72nd section, right? Because the last sheet. So by calculation suggests the cylinder that fulfills the condition. So the keywords here is the maximum volume. So the first, my strategy is I find the T72 because it is the last term, the last section. So I get the length is 1480, okay, millimeter, and then the height is 50. But it can also be like this. So the length is 500 millimeter, and then the height is 1480 millimeter. So yeah, it can be like that. So this is height. So which favors the most the maximum volume? Is it A or B? So that's why I do trial error. So for the first case over here, when for V1, so I choose the height is 50, and then the radius is, because we know that the length is basically the circumference of the cylinder, because we roll the cylinder to form a circumference of the circle at both ends. So we know that the length of the circumference of the cylinder of both ends is 2 pi r because it forms the circle. Okay, and the circumference is actually the length of this whole rectangle, the rectangular length, the rectangle length, okay, which is 1480 millimeter. Okay, so we can find the r, so just divide both by 2 pi like this, and I get the volume is this 8.72 times 10 to the power of 7 millimeter square. And for the second case, I make the height to be 1480 millimeter, and then the radius is this. I get the volume is 2.94 times 10 to the 7 millimeter. So the maximum volume is the first case, case A. Okay, so we need to choose the circumference of 1480 millimeter, whereby the radius is, well, 740 over pi, and the height is 50 millimeter, like that. Okay, so this is millimeter, I forgot to write like that. Okay, it's very easy actually, but quite complicated. Question 11. So we are given 6 numbered cards, so we need to find a different way of arranging them. Okay, because the question doesn't mention any restriction, so yeah, just straight away 6 factorial, 720 ways. Question 2. 4 cards are to be arranged to form proper fractions such that the even number cards are arranged side by side. Find the number of different proper fractions that can be formed. So I give you 2 versions of my answer. So first one is the arrangements which must include even number, and then the second one is the case when you can exclude it. Okay, you can exclude. So exclude and include. So first thing first, you need to know what is proper fraction. So proper fraction is when you have A over B and B is greater than A. In simple explanation is the denominator is greater than the numerator. So denominator is B, numerator is A. For example, you have 3 over 2. 3 over 2, so the numerator is greater than the denominator. So this is not proper fraction. So this is improper fraction. Proper fraction is like 1 over 2, okay, 2 over 3, 1 over maybe 12 over 31, like that. So this is proper, as long as the denominator is greater than the numerator. Okay, so for the first consideration is the arrangement must include even number. So case 1 we have, okay, of course we can have the fraction like this, and also for the second case is you have 2 digit top and bottom. Okay, so you can read away my calculation. So for case 1, numerator can be, you can choose, I mean, first we set the even number to be at the bottom because it needs to be side by side. You cannot put 2 here because it will omit the condition given by the question, right, which we don't want. So we need to put it on the denominator, so 2 6. Okay, then we left with 4C1. So from 4 number you choose 1. Because you already choose 1 here, you still have 3 left, so 3 choose 1. Okay, and over here you can see 2 factorial. Why? Because you can swap them, 6 2 instead. Okay, so you just multiply the combination and permutation, then you get 48 ways. For the second case, okay, this is actually more complicated one. So for the first Roman, so you have 2 6. I set 2 6 at the top. Okay, and for this I set 2 6 at the bottom. For the first case is you can choose 3 C1. Okay, why? Because you already use, okay, this even number you exclude, so you just left 1 2 3 4 4. Okay, 4. But you need to remember you cannot put 1 here, because if you put 26 over, for example, 19, so we have improper fraction, so we don't want this. So we can only put 5. What else? 7 and 9. So that's why 3, choose 1. And for this digit, you can put 1, so you still have a 3 left digit, so 3, choose 1. Okay, so for question for Roman 2 is the same logic. 26, you can put it 2 6 at the bottom. Okay, why I set 1 over here? Because you cannot have anything greater than 2, because it will be improper. For example, 5, so this is improper. Anything 50 something, for example 51 over 26 is improper. So you need to set as small than 2 for the numerator, for the first digit. Okay, for the second digit over here, you can choose 3 number from, you can choose 1 number from 3 left. Okay, and implementing the same logic, you will get at the end 24 ways, like that. Okay, you just add the first case and second case, you get 72 ways lah. So this is for the consideration if we include even number. When we exclude the even number, actually it is not so hard. Okay, so we don't have even number here, so we can choose 4. Okay, choose 1 for the numerator, and then for the bottom or the denominator we can pick. Okay, we use permutation because we can swap places between the numbers, so 3p3. Okay, so we just multiply, we get 24 ways. So this is okay for the second case. For the second case, which has two digit number for the denominator and numerator, I need to set like this because I want to avoid any possibility of improper fraction. So I set like this: 1 5 5 7 7 9. Okay, because I cannot just randomly use like this. I cannot just randomly like this is, because we exclude even number, so we left with 4. So 4p2, and then this is 4p2. So of course I don't want to do like this, because there is a possibility that the permutation will be like, for example 1 7, and this is 5 9. So we don't want this, so that's why I need to set the condition like this: 1 5. So this is to avoid the improper fraction, instead of 5 1 like this. Okay, I don't want like that. And then I just multiply everything, because we know that the second digit is 2c1, because we have 4 odds number, so we already used 2, so we left with 2c1 and 1c1 lah. Right, and yeah, we just multiply it because this is the same. Okay, 2c1 and 1c1, so we just multiply by 3. Right, so we get 6 ways. Alright, so after that we just add when we include even and when we exclude the even number. So everything altogether is 102 ways. So for question 11, so we have the combination of n objects from different object is given by MCN. So state the minimum value of n. So of course n can be 0 because n factorial is 0 factorial is 1. So if we let n equals to 0, so the MCN formula still valid because n factorial, 0 factorial is 1 lah, it's still valid. Okay, 2. Sarah bought a box of colored pencil that contained p number of different colored pencils. Given that the number of different way of Sarah to choose 3 pencils from the box is 26 bracket p minus 2, find the value of p. So this is actually PC3 because Sarah choose 3 pencils from the box. So the box has p numbers of different colors, so p choose 3. So just implement the formula like this. Okay, and then the number of different ways is given by this, so just equate. Because I know that p factorial is p times p minus 1, p minus 2, then p minus 3. I stop until p minus 3 factorial because I want to cancel it with the denominator. And then coincidentally p minus 2 also cancels with the left hand side, the right hand side. We left with p bracket p minus 1 equals to 156. Solve the quadratic equation, and then we arrive at p equals to 13 or p equals to minus 12. We need to reject this. Why? Because the number of pencils should be positive, can't be negative. So 13 is our answer. Question 12. So a random variable x has a binomial distribution with 5 trials such that the probability of success is p and failure is q. So this is actually the number of trial 0, 1, 2, 3, 4, 5. This is the probability. So the combined probability of x equals to 0 and 1 is this, and for 4 and 5 is this. Because we know that the total probability is 1, so we just minus 1 minus this and this, we get this 45 over 128. So this is actually the combined probability, not the separable probability, separate probability between them. So this is combined. Okay. B. Hence, show that p equals to 3 over 16q. Because the word here is hence, we need to use whatever we got from the question A. Alright, so px equals to 2 plus px equals to 3 is 45 over 120 from the previous question, right? We just apply the binomial formula. So I hope you still remember, and choose what? And choose R. Okay, p power r times q power n minus r. So this is px equals to r. Okay, so using the same formula, I get this like this. I factorize the p square q square, then I left with the q plus p in bracket. Okay, so that's the factor. Because I know that p plus q should be 1, so this is actually 1. And then I solve for p alone. I get p equals to 3 over 16q, then hence shown. Okay. Alright, so this is for part B. Alright, it is given that fx equals to this and fgx is this. So find the object of fx if the image is this. So remember that the object is x, is the object or the domain, x value. Okay, x value, and y value is the y value of or fx lah, fx value is the image. Okay, so just implement this. Image is 1/3, so you find x is 5/2. Okay. B, express m in terms of p if fm plus 1 is 3 times fgp. So first find fm plus 1, which is this. Sorry, no, which is this. So I need to equate with the, this is actually 3fgp. So okay, so I just, from here I just multiply 3 and then subs in p, replace x with the p like that. So I get like this 9/4p squared plus 3. I just solve the algebra, I get m equals to this finally. Okay. Alright. For question C1 is to find gx. Because I know the gx is the inner function of fgx, so I can assume gx exists first, because this gx I put inside f function. So just imagine I have gx here, I just put gx here, gx here. Okay, so I'll get like this. Okay, 3/f times gx minus 1 equivalent to this. So this is actually fgx, the one given by the question over here. Alright, I just solve for gx, I get gx is x squared plus 1. Okay, so for question C2, using the okay, what is the question? Hence, determine whether the inverse function of gx exists or not. Give your justification. So in order to find either the inverse exists or not, we need to use horizontal line test, HLT. So horizontal line test, because I know that this is actually quadratic curve, so assume that it's like this. Okay, so this is assume lah. Right? No, because it has no real root, so I guess it should be like wait, let me think. Should be like this, right? Okay, gx x squared plus 1. Okay. So horizontal line test. So for my previous solution, I choose y equals to gx equals to 2. So it's like over here lah. So this is actually 1. So this is actually y equals to 2 lah. So I choose the horizontal line or the horizontal line. Yeah, horizontal line. This is x, gx, which is y equals to 2. I try to subs. Okay, when I subs, I get both two values, x equals to plus and minus 1, which means that it has two objects for one image. In that case, that the function fails the horizontal line test. Because it has two object for one image, which is many to one relation. In this case, it has no inverse because it fails the horizontal line test. As simple as that. Question 14. So this is a triangle, right angle triangle, because it has the symbol or indicator like that. Well, guess what? Just use theorem Pythagoras like I did. You can see how I did. A squared plus b squared is c squared, like this. Okay. I did some simplification. You can actually let 2 power x is, for example, y. So you will have supposed to be 4y squared plus y minus 18. So probably this form might not be so obvious for you to see it is a quadratic equation, So you can let first y equals to 2 power x, and then you can see it is actually obviously a quadratic equation. You just solve for y, and then you get I get like this, 2 power x equals to minus 9 over 4. It is rejected because if you try to raise by ln, so you can see ln of a negative number, negative input, it is not valid. I mean, it is not defined in logarithmic function, so it is rejected. But you have still a second option, which is 2x equals to 2 or 2 power 1. So just compare the power x equals to 1 like that. Okay. B, this is a trapezium. So it is given that the area of the trapezium is this. Express t in the form of p plus q sub 7 such that p and q constants. So you just use the formula 1/2 area of the trapezium is half a plus b times height t. So a is 5, b is sub 7, t is not given, equals to this. So this is given by the question, the area. So if you see the surd at the bottom of the fraction, you need to rationalize it by multiplying the conjugate, both top and bottom, by the conjugate. So conjugate of the denominator, not the numerator, alright? The denominator usually. But sometimes sometimes you need to multiply by the conjugate of the numerator sometimes. But in this case, you need to get rid of the surd at the bottom. You need to multiply by its conjugate, which is 5 minus 7. So you need to multiply the same thing, top and bottom, alright? After multiplying and simplifying, you get 6 sub 7 minus 12, or minus 12 plus 6 sub 7, so as the question wants. So we know p is minus 12 and q is 6. Okay, the last question actually. 15a. It is given that x squared, where is x? Sorry, it's already 2 o'clock at the night, so I feel a bit confused. So it is given that x sine x equals to t such that x is an acute. So acute is the angle between 0 and 90. Express sine 2x in terms of t. So first I evaluate the sine 2x first. So using the double angle, you get sine 2 times sine x cos x. Because I know the sine x is t, I want to find cos x because I don't know, I don't have any information about cos x. So I use our favorite right angle triangle. So because the angle is x, so sine x is t. So I know the sine x equals to t over 1. So opposite over hypotenuse. So opposite is t, hypotenuse is 1. So the adjacent is sub 1 minus t squared. Okay, so from there we can find cos x is adjacent divided by hypotenuse, which is sub 1 minus t squared divided by 1. Just subs in, you get like this. B, given that cos theta is k for this angle, so this is fourth quadrant angle, express half angle of cos in terms of k. First off, I love to do to let the variable of the half angle to be any other variable. In this case is theta over 2. The half angle is I let it to be x. Okay, similarly 2x equals to theta, right? Okay. Because I know 2x is theta, so I subs back into this. So it's like this. I apply the double angle formula. So cos square x minus sin square x equals to k. Why? Because it is given that cos theta is k and theta is 2x. Okay, so it is k. So k equals to cos square theta over 2. Why theta over 2? Because we know that x we let just now is theta over 2. X is theta over 2. Okay, so it's like this. So I don't want anything in terms of sine squared theta over 2, so I just substitute, because I know the relationship sine theta is sine squared theta is 1 minus cos squared theta. Okay, so this is the relationship you need to know. So I just substitute in. I get like this. Okay, I make cos squared theta over 2 as a subject to be like this, and then I just square root both sides, plus and minus, because I know k should be between this, so k is positive, because for this cos theta equals to k, so theta is in the fourth quadrant, so fourth quadrant cos is positive, so k, which implies k is positive. So positive number plus 1 divided by 2 is a positive number, so this is positive number. But you need to know that because we need to consider the half angle theta over 2, so you can divide both sides, or divide both sides by 2. So 270 divided by 2 is theta over 2. Is it? Yeah. So this is actually in second quadrant. So cos in second quadrant is negative. Okay, so cos in second quadrant is negative, which means that cos theta over 2 is negative. So we need to consider the negative possibility of the square root lah. So I have here negative square root of k plus 1 over 2 as the cos theta over 2 answer. Okay, last one. So we need to find what? Find the value of tangent 22.50 degree in third form. Okay, so this is actually half angle also, but I remember that the double angle formula for tangent is like this, so I already derived from the basic principle. So tan 2x is 2 tan x divided by 1 minus tan square x. I want to substitute x equals to 45 over 2. Okay, so I will get like this, tan 45, which what we want, equivalent to 2 tangent 22.5 divided by 1 minus tangent square 22.5 equals to 1. So if you can see, this is actually a quadratic equation by letting tan 22.5 x. Okay, so 2x equals to 1 minus x. Sorry, 2x equals to 1 minus 2x squared. So x squared is x squared plus 2x minus 1 equals to 0. So you can solve this by completing the square, CTS, or formula. So I choose using formula, b squared minus 4ac. Okay, so like this. So I solve for tangent 22.5 as the question wants. At the end I get this. Because for the formula you have plus and minus, you need to consider the plus version of the answer. Minus 1 plus square root 2. Because if you take 1 minus square root 2, so this will yield a negative number. But tangent 22.5 is in first quadrant. So any trigonometric ratio in first quadrant should be positive. Okay, if the angle is in first quadrant, the trigonometric ratio sine, cos, and tangent of that angle should be positive. So we need to take minus 1 plus 2. Okay, yeah, I guess that's all for our discussion. We already finished this paper 1 SPM at math 2021. So the answer is suggested by me myself. And yeah, till next time, thank you.